In this video, we're going to turn parametric equations into its Cartesian form. So let's say you've been given these parametric equations for t being greater than 0. Our aim is to turn these parametric equations into its Cartesian form, y equals something. So the trick is to somehow eliminate the t. So somehow eliminate the t. If you look at this, this is exactly the same as this. So now I'm just going to bombard you with lots of examples. After a while, you can see some of the tricks that you can use. So if you look at this, this is exactly the same as this. So if you consider this, so at the moment x equals this, y equals this. If you consider x plus y, so add these two together, because this is exactly the same as this. Then when you add the two together, these two will cancel each other out, leaving you with 2t. So the trick to eliminating the t, well, the first part is to consider getting this, take away this. So hang on, let's start again. So the trick is to consider getting this plus this. So getting this plus this. So this thing would be, well, if you get this plus this, it will give you 2t. And then that's the first part. Now the second part is to consider getting this, take away this. So this thing here, so consider getting x take away y. So this thing here is this thing here is this thing. Now if you tidy this thing up, it will give you 2t. So considering x plus y will give us this, considering x minus y will give us this. Now the trick is if you get these two and multiply them together, you will eliminate the t. So consider getting this, which is this thing here, times this thing here. That will then be this times this. That will be 4. So now you've eliminated the t. So that's a trick we would use. And at the moment you don't know all the tricks. So I'm just going to bombard you with lots of examples, and then after a while you will get a sense of what to do. So that will eliminate the t. So tidy this thing up. That will then give you this. Now if you get a graph plot and plot it, it will give you this. So remember, right from the start, we said the domain is that t being strictly greater than 0. Because if you put 0 into here, then you're dividing by 0. So the whole thing here breaks down. And then if you put 0 into here, the whole thing here breaks down. So t cannot be 0. So let's consider t being very, very close to 0. So let's consider this. So now if you put this into here, this thing here would be very, very, very big. If you put this into the t here, this will be very, very, very small, because this is very small. Now if you add the two together, overall it would be very, very, very big. So in the x direction it would be very, very big. Now if you put this in here to try and find out where the y location will be, if you put this into here, this thing here will be very, very, very big, and then put this into here, this thing here will be very, very, very small, and then you've got your takeaway. So very, very small, take away very, very big. So it's going to be minus very, very big. So in the y direction it will be all the way down here. So you can imagine this being all the way down here, because when you put a small t into here, this thing here will tell you that x has to be very, very big. So the location in the x direction will be somewhere all the way to the right. If you put this into here, the y location will be all the way down here, which is somewhere around here. So when t is small, the location will be somewhere down here. Okay, so now let's consider when t equals 1. When you put t equals 1 into here, this will be 1, this will be 1. So the x location will be 2 right here. If you put t into here, this thing here will be 1, this thing here will be 1, 1 take away 1, the y location will be 0. That's why t equals 1 would be right here. And then you can use the same argument, put t to be very, very big, put t to be very, very big. And then use the same argument. This thing here will be very, very, very small, and so on. It would take you to somewhere up here if you use the same argument. So when t is very, very small, t equals, let's say 0.000, it will be somewhere here. When t equals 1, it would be here. And then when t is very, very big, it would be somewhere up here. Now, if you consider t to be minus, it will give you something, well, this bit here, you have to think for yourself, okay?